Lilia.
I'm Victor.
I'm Lucian.
And I'm Remus.
And we are team
IQube!
We'll present you our entry for the Software Design Imaging Cup competition called LiveX Learning Platform.
LiveX Learning Platform addresses the field of education by offering students from all over the world hands-on practical science, experiments and educational games. It is a very cost-efficient solution and of great benefit for schools which are facing very low budgets. Many children are learning science just theoretically and are stiff bored in learning with pencil and paper. The step from theory to reality is for them just a dream. So let's imagine, for example, how we can express the physics laws of motion in a more engaging way. We could use, for example, an inclined plane and then some specialized laboratory equipment such as a LabQuest device for displaying graphs and force sensors. It sounds very nice, but the reality looks way different. Here you can see the physics laboratory from a school in a rural area from Romania. It's a drawer full of scrap. They didn't receive any laboratory equipment for more than 22 years. So we can't do this physical experiment here. On the other side, there are schools in Nepal, near Kathmandu. They also don't have the necessary laboratory equipment, but they receive some computers through donations. So our second idea was to make some software simulations for that experiments. So this would be an example of such a software simulation on the PC. There are already some companies like Blackboard Learn or All Educational Software who are selling such educational laboratory science simulations. But the schools also in Nepal don't afford to buy such software, and they also don't have the necessary personnel to maintain those PCs. Looking at some prices, we can see that the costs for equipping a science laboratory are around $3,000 US. Also, the license for simulational software is around $2,500. The next thing we did is we thought about what kind of sensors do we need to make science experiments. So the result was that we need some accelerometer sensors to measure force, speed, angle. Also we need some sensors for audio stream to record audio, to analyze audio. Also we need some optical sensors to see images and analyze some images. So thinking at that, we realized that we already have those sensors in our pockets. And I'm talking here about smartphones, tablets, and the third thing are some smart cubes called IQubes with LCDs on every face that we built specially for students to use in experiments. Let's have a look how we can make the experiment with the inclined plane with a mobile device.
We will now perform an experiment using an inclined plane. We want to see the velocity and the acceleration of a sliding object on each point. Here are the instructions. First, we place the phone on the plane. We press start and let it slide. Now we press stop and we'll see the graph of the motion. And now we can get the velocity and acceleration in each point, which we can use to check Newton's law of motion.
Coming back to the IQubes, you can see that there are some cubes with LCDs on every screen, and they have different sensors, such as an accelerometer, some wireless to connect to the internet, a speaker to play sound, some RGB LEDs, and Hall sensors which give them the ability to sense each other. Let's see a short demo with the IQubes.
In this experiment, we want to teach the children numbers. On one cube we have the numbers from 1 to 6, and on the other cube we have the same numbers spelled in English. Children will try to associate the corresponding number with its corresponding word. When the answer is correct, the cubes will turn green, and when the answer is wrong, the cubes will turn red. Now let's see how the exercise works. We have on one cube the number 2 spelled in English, and on the other cube the number 4. When we try to associate the cubes, the solution is wrong. We try to take the right solution, and when we associate them, the solution is correct. In this next lesson, we like to simulate a chemistry experiment. We all know that the mixture of hydrogen and oxygen results in water and sometimes a small explosion. When mixing the two elements, the quantity of the elements matters, and when we try to mix them as shown, we see that nothing happens. When we modify the concentration of these substances, when joining them, will result in a small explosion. If the mixture is modified so that the ratio is 2:1, it will result in a bigger explosion.
So basically, our LiveX learning platform consists of a software platform that runs in the cloud and some end devices like mobile phones, tablets and IQubes that users are manipulating and creating experiments. Let's have a short look on the architecture. Basically, our solution is built on the Microsoft vision of 3 screens and the cloud. So our LiveX platform consists first of the end devices, so the IQubes, the tablets and the phones, which are communicating with the logic which runs in the cloud. So all the experiments logic is run in a workflow engine. Also, the teachers can access the software platform and create experiments very easily through an ASP MVC3 web app. Here you can see a simple example how a teacher can create an experiment.
So, let's create an experiment. We want to create an experiment which determines if white light breaks down into the primary colors of the spectrum. For this, we start simple. We start with the name. In this case, light breakdown. Now, we need to figure out what we need for this experiment. For this experiment, we need an input argument that is an image and an output argument that determines if we want to show the spectrum, or if we don't want to show the spectrum, so a Boolean value, which we are going to call result. Now we need to figure out how this will go down. This is a sequence of events in which first we will determine the percentage of light in our image. Since we have design time support, we will get errors in real time. In this case, the error is there because we don't have a variable assigned. So once we create this variable of the right type, the error will go away. Now, when we have the light percentage, we must set a threshold. So, let's say this threshold is 80%. If the light percentage is higher than 80%, we want to show the spectrum, so we will assign true to the result. Otherwise, we will assign false to the result. Once this is done, we simply save the experiment and move on.
At the heart of our system stands a VCF service that communicates with the workflow engine, with the end devices, and the ASP MVC3 web app. It's the heart of our system. So, when the teacher created the experiment, he can download a Microsoft tag. So students can come to the laboratory, take some mobile phones and smartphones, then they can scan the tag and register successfully for the experiments. So all the images, text and all the data for the experiments will be downloaded on the phones. Let's have a look on another experiment.
First, we choose the experiment, light spectrum experiment, and there is a short description of the theoretical knowledge and the steps you should follow to achieve the experiment. We press start and the camera starts recording the light, and when the light is strong enough, we will see the light spectrum. We will now perform another physics experiment in which we study the centrifugal force. The experiment follows the same pattern. We have the description of the experiment and the instructions. We press start, and if the glass is inclined enough, the water will spill. However, if we spin the glass fast enough, the water won't spill because of the centrifugal force.
A good business plan is very crucial for a software project. So, let's talk about some costs. We made the math for 50 schools regarding the Microsoft Azure hosting, and we came up with a price of $4 per month per school. Also, we made a LiveX kit consisting of 6 IQubes and an inductive charging pad. So the teachers just need to put the IQubes on that charging pad and they will be charged. So such a kit would cost $90 US. Also, looking at normal laboratory equipment and our solution with the IQubes hardware platform, our solution is with $850,000 cheaper when we look at 25 schools in a time span of 10 years for our solution. First, it's a cost-efficient solution. Second, it gives hands-on experience to the students. Third, it's a long-term solution because we can use any kind of hardware. The software doesn't get outdated. And not at least, it's a very engaging solution. And when I say engaging, I mean that we went to kindergartens to test our solution, to get feedback from the children.